Alright, now I want to talk about the various work holding devices. On this machine I have set up a 3-jaw chuck. Now the 3-jaw chuck is the easiest one to use, but it's also the most inaccurate way to do something. The 3-jaw chuck, on the inside of here there's what they call a scroll plate. And as I work the chuck, if I use the chuck key in here, and as I rotate the chuck key, you will see that all 3 jaws open at the same time. It's a lot like a drill chuck in a way. And if you turn it the other way, they all close at the same time. To use this, you want to put your workpiece in the 3-jaw chuck. And it will hold it securely and sort of on center. Like I said, this is the most inaccurate work holding device. The problem is the part is only as centered on the machine as this lets it be. This could be off center as much as 10 thousandths even, and there's no way to correct that. This is a contained unit and there's no adjustment on this one. Safety rule number 1 is never leave the chuck wrench in the chuck. Never take your hand off of it until you are done using it. If you leave the chuck wrench in the chuck, that is a major safety violation, because if this machine would start, this chuck wrench comes flying out, it could hit you or anybody else around here. So do not leave that in the chuck. So the 3-jaw chuck is the easiest to use, but the most inaccurate. Now if you want, you can take these off. If you look on the spindle, there are these screws. These are actually cams. You can unlock each one of these cams. The chuck can then be removed and you can put on another work holding device. The next work holding device I'd like to talk about is the faceplate. The faceplate is actually just a driver for the shaft. The shaft is actually held between centers on the lathe. Inside the headstock there'll be a dead center, and on the tailstock there's a live center. The dead center in the headstock looks just like this one. So this is inside the spindle. My part has already been faced and center drilled on both ends, so the center drill on the shaft is actually on this dead center. In the tailstock, there's a live center. The difference between the live center and the dead center is that the live center has an internal bearing. So as you can rotate, as the shaft would rotate on the tailstock, the bearing would rotate. The headstock dead center rotates with the spindle. As the spindle rotates, the center will rotate. Typically, you do not use dead centers in a tailstock. If this dead center was in the tailstock, that friction would be created from the rotating shaft against the stationary center. So most typical setups use a live center in the tailstock, the dead center in the headstock. So if your part is faced and center drilled and it is in between centers, you need a lathe dog also. The lathe dog actually provides the driving force for this. Inside the faceplate is a slot, and that's what the lathe dog relies on to drive on. So as you rotate the part, it is driving with the lathe dog against the shaft that rotates the shaft. This is the most accurate way to get something turned on one common center line, because you're always working off the center drilled holes and you're always keeping it on center. The next work holding device I'd like to talk about is the 4-jaw chuck. The 4-jaw chuck looks like a 3-jaw chuck, except that it has 4 jaws. Now this is called an independent 4-jaw. Every one of these jaws can be adjusted on their own. So as I turn this jaw backwards, you will see that the jaw moves in and out. The other 3 jaws are not moving. You have to adjust each jaw independently. This is also a precise way of keeping things either on center or deliberately off center. When you go to do a setup with one of these chucks, you will need to use a dial indicator. This dial indicator monitors the movement or the run out of the workpiece. I'll do a separate demonstration on this later, but just so you know, the dial indicator has to be used with a 4-jaw chuck. The 4-jaw chuck can be used to hold irregular shapes, or you can purposely hold anything off center. I made this keychain in a 4-jaw chuck. You can deliberately make things on different center lines. The next thing I'd like to talk about is tool holding. Work holding devices hold the workpiece. Tool holding devices hold the tools. So if you look up on top of the carriage here, I have the tool post. This is a dovetail tool post. This dovetail tool post allows for quick changes between different tools. This dovetail, if you look at how it is shaped, fits on this dovetail. So you have to have the handle open. You can install that and then clamp it. So this wedge right here actually is what tightens it. You'll see when I close that, that wedge actually moves down. On this kind of tool post, with this tool holder, we have this adjusting screw. This adjusting screw controls the height of the tool, and we'll talk more about that later. What's nice about these tool holders, as long as everything is clean, they remain accurate. But what's nice about that is I can switch from a turning tool to a knurling tool. On this dovetail tool holder, there's 2 dovetails. I can put tools here or on the back side. This is typically used for boring bars. Another tool holding device is the old rocker tool post, or the lantern style tool post. So with this lantern style tool post, the tool fits underneath this long screw, and there's a half moon key in the bottom of there. You can angle this in any direction, and you can control the height of the tool here by moving that half moon key. You can change the angle of your tool and the elevation of your tool. When you have it set where you need it, you tighten this down with a wrench. The one we're going to be using in our demonstration today is the dovetail tool holder. As you can see, I have various different tools set up here. So I could put this one on the quick change tool holder. I could switch to this one, a knurling tool, or any other tool that I want to put in there. On your milling machine project, you made a lathe tool holder. This is the one that you will make in class. This is designed to hold on to the smaller tool bits that we have. When you use this, this is actually the bottom of the tool holder. It's the thicker part and it's stronger. So when you go to put it in there, you want to make sure that the top of your tool is up, and then the thicker part will support it. This then fits in this tool holder. So the reason why we use this is because this tool bit's a little bit too small for this tool holder. If I didn't use the tool holder we made, this would be kind of, it would work, but it's not a real good setup. Another tool holding device is the tailstock. A lot of people do not realize that the tailstock can be used to hold cutting tools. The tailstock has a taper on the inside. The taper on the inside is called a Morris taper. If you have a taper shank tool with a Morris taper, that will fit inside the tailstock. Typically the tailstock will have a tail center in there. This is a live center with the bearing, and it's mounted in the tailstock. That taper is a self-holding taper. If you back the quill all the way into the tailstock, it will release the tool that's in there. You can remove that. So if you want to take out the tail center, you could put in a drill chuck. So now this drill chuck, you can put drills in there. This, you just snap in there. You just snap it in there, and it holds it securely. You can then chuck straight shank tools in there. For a taper shank tool, you have to make sure you match the right taper size. This taper is too small for this size of shank. So if I try to put this in the tailstock, it's not going to fit. So if your taper is too small, you need to put on the taper sleeve. You line the tang up with the slot, and you just snap them together. Now this will fit inside the tailstock. So you can now do large drilling with a lathe. So the tailstock can be used as a tool holding device. And once again, to release this, you just back it up till it retracts fully and it'll pop it out. Now to remove the taper from the tool, which you need to do before you put it away, there's what they call a drift pin. You insert the drift pin into the hole, and you'll use a hammer then to tap on the pin. When you tap on the pin, you'll notice I'm going to hold the drill with 2 fingers and the sleeve with 2 fingers, and I'm going to squeeze it so nothing goes flying here. And when you tap that wedge in there, it actually wedges this apart. You can then remove the sleeve from the drill. So those are the various tool holding devices that we have. We talked about work holding and tool holding devices. The different work holding devices are 3-jaw chuck, between centers, and the 4-jaw chuck. The different tool holding devices could be the dovetail tool post or the rocker tool post. On either one of those tool posts, you can put on your left-hand turning tools, your straight turning tools, or your right-hand turning tools. Grooving tools, threading tools, knurling tools. There's a lot of variables you can use for tools when you're using a lathe. And I'll try to demonstrate some of those as we go through this course.